This right here is a picture of Fibonacci. Fibonacci, one of the most famous mathematicians of all time, and he was a mathematician in medieval Italy. And he's most famous for the Fibonacci numbers. Fibonacci numbers. And he didn't discover them. They were actually discovered several centuries before him in India, but he popularized them, especially in the West. And the Fibonacci numbers are super simple. The first two are defined as 0 and 1. And every number after that is the sum of the previous two. So what I'm constructing right here is really a Fibonacci sequence of numbers. So the next number in the sequence is going to be 0 plus 1, which is 1. Then the next number after that is going to be 1 plus 1, which is 2. Then the next number after that, 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 is 13. 8 plus 13 is 21. 13 plus 21 is 34. And the Fibonacci numbers, especially once you start getting into number theories, tons of fascinating things about them. But probably the coolest thing about them is as you add more and more terms to the Fibonacci sequence, and you take the last two terms that you've generated, obviously, there is no really last two terms. You could keep going on forever, get arbitrarily large Fibonacci numbers. But say we take these last two terms over here, 21, 21, and 34. If we take the ratio of these two, 21 over 34, this is going to be pretty close to the golden ratio. Pretty close to the golden ratio. And I encourage you to look up the golden ratio on Wikipedia and the internet. You'll find all sorts of fascinating and mystical things about the golden ratio. What's cool about the Fibonacci numbers, or the Fibonacci sequence, this gives you an approximation of the golden ratio. But you'll get even a better approximation if you add another term to our sequence. So the next term over here, 21 plus 34 is 55. So the ratio of 34 to 55 is even closer to the golden ratio. So one way, if you wanted to compute a really good approximation for the golden ratio, you can really just get super high Fibonacci numbers, just adding the previous two terms to get the next one, and you will get a pretty good approximation when you take the ratio of the last two terms. Now that's what the Fibonacci numbers are about. And now I want to pose a challenge to you. I want you to write, since we've already done some examples using factorial, I want you to write an implementation of a function that generates the nth term in the Fibonacci sequence. So the function will be like this. So this will be in the Fibonacci sequence. So if I call your function, let me make it lowercase. Let me just give you some examples. So if I take your function and I call Fibonacci, and you can really implement this in any language you want, although we've been dealing in Python, and it might be simplest to do it in Python. If I call Fibonacci of 1, what I want this to be is the first term. And just to make things clear, and you should always clarify this, especially in computer science, because it's not always clear what the first term is. And I'm going to make it clear right now. The first term is not going to be this one over here. I'm going to make it this one over here. I'm going to call this the 0th term. That's the 0th term, and then that is going to be the first term. This is going to be the second term, third term, fourth term, so on and so forth. And so Fibonacci of 1, the first term will be this right over here. It should return 1. Fibonacci of 0, so Fibonacci of 0 should return 0. Fibonacci of 3 should return 0, 1, 2, 3. It should return 2. Fibonacci of 5 should return 0, 1, 2, 3, 4, 5. It should actually return 5. And what I want you to do is write a function so we could put in any argument over here, and it'll return that third term of the Fibonacci sequence.